And as usual, we will leave 10 minutes or so at the end to answer your questions. Surely you have questions before you've come here, or questions that may arise by the end of this class. So first, we want to define some key terminology, right? At the center of what we're going to be talking about is this word cloud. Okay. Once we establish the meaning of cloud, we will then briefly establish the meaning of cloud computing, what that means. Again, this is relevant to you, whether you are trying to use data, whether you want to, like I said, put an application online for your business or your service, or no, you're just someone who wants to enter this field of software data, as in you want to assume a new profession. Now, relevant to both of these disciplines is this thing we call an API. This is a word that is thrown around a lot, but still seems to be elusive, right? Many people still are not sure what an API means. We will define that. And of course, we will define it with examples. What are the things you can do if you could get hold of this thing we call an API? And of course, I want us to do a simple example of API, just to show you how really simple it is. It's really more straightforward than, I guess many people make it out to be. And of course, like I said, if you have any questions, I'll be answering those. Topic number one, what is the cloud? Before I ask this question, I just want to gauge your familiarity with this word. Those in the chat and those here in person, what does this word mean to you? Kind of storage, that's one word. What's another one? What's another? Give your definition. What do you think the word cloud means? So storage, technique, those are the two words.
Another person's computer.
Another person's computer, okay. We said storage, technique, computer. So far, three terms, all contradicting each other. Okay, but it's not very far off from the correct answer. How about you, sir?
It's like a virtualized infrastructure.
Virtualized infrastructure, okay. Again, I'm talking about the word cloud specifically. We have cloud compute, but that's a good guess. And how about you, sir? What do you think? When you hear the word cloud, what pops into your mind?
A remote storage of data, accessible anywhere, everywhere, anytime.
Iti in the session says online. Is that your definition of cloud, Iti? And do let me know if I pronounce your name correctly. The answer, let's look at the answer. The answer to what is the word cloud is the internet. I think this term was coined in 2004, 2006. Definitely the former CEO of Google, Eric Schmidt, had used this term very early on. And they asked him, what does this thing mean? He just said, it's the internet, just a marketing gimmick. We wanted to make it sound, futuristic, impressive. So we just call it cloud. Cloud, internet, same thing. Okay. Now the next question, if the cloud just means internet, what is cloud computing? I forgot to put in the word computing, but what is cloud computing? Okay, so we said storage, right? You said technique. What was your answer? You said it's a virtualization. So, bingo. If cloud is internet, then cloud computing is computing over the internet. That's precisely the definition. Now, if we want to get a little technically precise, we need to, we need to specify what it really means to compute on the internet. How does this computation work? And what's so special about cloud computing? There are three components that we need to look at. The hardware that is used in this cloud computing phenomena, the software, and the programming paradigm. Okay? The hardware and the software we use in cloud computing, if you think about AWS, Azure, IBM, Red Hat, all of these big cloud vendors, the hardware and the software that they use is not, it's not exactly revolutionary. Okay, the techniques they have been using has been around for a while. In fact, it goes back to the 50s. Okay, anyone heard of the word supercomputer? Right, you've heard of supercomputer. What comes to your mind? Like a machine that is super, especially fast, right? Well, we don't use the word supercomputer anymore because what made a computer supercomputer was the underlying architecture, like how you assemble the hardware. Today, every computer in front of you, your laptop, your smartphone, your tablet, these are considered supercomputer, right? Yes, your laptop may be more powerful than your smartphone, but they have the same architecture. So they're both considered supercomputers, right? I mean, when your smartphone, you can take pictures, you can do videos, you can edit videos, you can run all kinds of applications. So these are supercomputers. The term we use now is high performance computing. The idea is what makes cloud computing, what makes it special is how we combine the hardware that we have today and the software we have today to run multiple applications in parallel. Okay, so we are taking existing technology, but we are thinking about arranging them in a special way. Here's another picture, right? When you Google the word cloud, when you search for the word cloud or data center, a picture like this pops up, right? I'm sure you all see this. I think even in the third Matrix, the third Matrix movie, there was a scene where Neo was running, and there's these computers. They look like fridges, don't they? These are computers. These are also supercomputers. There are three parts to these computers. This is one from Dell. Dell, which makes personal computers, if you do not know, they're especially, well, they specialize in producing these types of computers called converged infrastructure. They distribute these to AWS. So this is their specialization, right? They may not have the biggest share when it comes to personal laptops, but when it comes to cloud computing, they know their stuff. And there are three components that go into every single one of these stacks. These are the same components that your laptop has, that your smartphone has. It's just that they have more of it. They have processing chips, just more powerful, more cores, just faster, better. They have networking components, right? To be able to receive internet connections, in particular to be able to connect to other converged infrastructures in the data center. And storage, lots and lots and lots of storage, right? Your laptop comes nowhere near computer like this when it comes to storage. Again, these are just like the computers you have, except they don't have a monitor, they don't have a touchpad, trackpad, keyboard, because it's not meant to be interfaced directly. Why is a computer like this used? A computer like this is used to be put into a housing unit, we call a data center, and these computers, they can be put into a cluster, and they can accommodate hundreds and thousands and millions of customers. Okay, if you go to an AWS data center, by the way, these cluster of computers can be hosting applications for all kinds of companies, financial companies, healthcare companies, SMEs, enterprise, you name it. They have applications running, they have application data running on these computers. Okay, now the reason I'm telling you this is because it's relevant for what we're going to be talking about next. We have to clarify what cloud computing means. Okay, now, two key concepts before we go any further. The words host and the word client, the words host and client. I think you may be familiar with these two words, right? Host and client, what do you mean? Well, let me make it very simple. Remember, this is the data center we talked about, right? Which we said can host hundreds and thousands of customers. And they can allow millions and billions of customers to make requests directly to this computer. For example, when you go to Amazon and you're searching for a product, Amazon, the e-commerce store, right? Or when you go to Bizzle, or if you go to, let's say, youtube.com, netflix.com, right? When you click on play for that button, or when you click on that product added to your cart, you're sending a request to that computer, or those computers that are hosting the YouTube platform, the Netflix platform, or the Amazon platform. Okay, but who is making the interaction? Your computer is, right? This laptop, this smartphone, this smartwatch, any computer on which that has access to the internet and is making requests to this data center, we call that the client. So this is a client, this is a client, and this is a client. These are the clients. Okay? The clients are the devices that are making HTTP requests. Okay, all of this exchange. So when you type in www.youtube.com, okay, what do you see when you hit enter in the URL? The YouTube website comes to you. So you use, not you directly, but your device makes an HTTP request to the host, which in this case is which website? The YouTube website. And the YouTube website in turn starts giving you HTML content. Then when you hit the play button, it starts to give you the video content, right? So the way with which you exchange or you have this correspondence is HTTP. All right, are we all clear about this? That's all there is to it. This is relevant for the definition of API, which I say is a word that is abused. And you'll see why it's abused when I ask everybody the next question. What is an API? So like before, I want everyone to give me the definition. 1 or 2, 3 words max. What is the word? What do you think the word API means? What comes to your mind? An address? Okay, an address, what do you think? No idea? How about you?
It's like a handshake contract between two programs.
Handshake contract between two
Kind
programs.
of like
Agreement. Okay, so agreement, and you say what? Address, agreement. So far, two contradicting terms. How about you, sir? What do you think API means?
I have no idea, but application platform over the internet.
Application platform over the internet. Okay, so platform. How about you? No idea? Any other guesses? You can just make wild guesses, right?
Anything that connects between two applications?
What's that?
It's like a connector between two applications.
Connector between two applications. Okay, right? How about you? What do you think API means?
I can't really explain, but I think it's like you said, something related to the address where we're going.
Something related to address.
Integration.
Some kind of integration. Mariam says interface. Now, API is an abbreviation for application programming interface, which doesn't really help us. It's such a vague application programming interface. What does that mean? Now, do you see what I mean when I say this word is abused? There's no consensus what this word really means. This is why this word is terribly abused. They think of something, they say something, but they really mean something else. So the answer to the word API is rules, communication rules for the host and the client. That's all that it really means. Let's say you have your application. You built a website on your own with HTML, CSS, maybe some PHP, JavaScript, okay? And you want to upload pictures to Google, right? You can pay a small fee to store your pictures on the cloud, right? Cloud computing, remember? But in order for you to provide or send your files over to the Google Cloud, you must, do what Google asks you. They have rules. For example, if you want to host files on Google Cloud, you need to create an account. Obviously, before you can even use any of their many services, you have to give them a credit card, right? They won't give it to you for free. If you exceed your threshold, they will charge you. So you need to set up billing. When you set up your billing, you'll be given what we call a token. That token is like an ID. Every time you make an HTTP request to the YouTube server or the Google server, for example, Google will look at the token and go, I know who this customer is. They're using this service or they're using that service. Twitter, for example. There was a time where we could use Twitter to gain access to, I think, 1 or 2% of all of the tweets they have. Eventually, they deprecated. They changed the rules. Do you know which social media company really changed their rules? What's a social media company that has been in the news a lot lately? Facebook. Facebook is a company that had to revamp the rules a lot because of how their API, how their rules, were abused. I remember, I used to build applications for our client. We would build games, and when people would associate their account with the game, you could see all of their information: date of birth, their name, the gallery, and not just them, but information about their friends. So even if you are very safe with your account, with your social media accounts, just because you have a friend who's a bit careless or you just don't know what they're doing, your information is now exposed. And there was a big event, and they said, you know what, we're going to completely change. That URL that you use for making HTTP requests is no longer valid. We have a new API documentation. If you want to interact with their Facebook host or their Facebook application, these are the rules you must follow. Okay? Now that we've clarified this word API, okay, and we no longer will abuse it, hopefully, let's look at some examples of API-based services, right? And when I say API-based, I mean if you make the right kind of request, you can get these services available to you. And here's a list. Again, the list is very extensive, and this is by no means an exhaustive list. Let me put it to you another way. Anything that you can do on the internet, any form of data, any form of exchange you can have over the internet, you can create an API for it, so to speak. You can create a documentation, and you can facilitate this exchange between the host and any other client. But let's go through some of the examples. Let's say that you have a company, or you want to build a company, and you have a startup idea, you have a software, and your application collects analytics from Google. I'm sure like page impressions, bounce rate, the traffic from different countries. You also have analytics from your social media accounts. How many times your tweets are viewed, how many times your pictures are liked on Instagram. I don't know. What's another social media platform? LinkedIn, right? How much views your LinkedIn posts are getting. And you want to do what? You want to consolidate them all into one beautiful dashboard. And your customers can say, hey, you can tell your customers, pay us out, we can get a subscription in our application, and you can have all of this information for your company from all different social media apps or website in one place. Okay? If you know how to make that exchange between the LinkedIn platform, the Twitter platform, the Instagram platform, and the website, if you know the API, so the rules, you can facilitate this for your client. Assuming you know how to put together a dashboard, we can make that happen. Storage. You have all kinds of file formats, and so we need different kinds of storage. If you want to store pictures, if you want to store videos. By the way, if you want to host videos, if you want to put a video on your website, on your landing page, hosting a video is a lot of work. Have you noticed how on YouTube, when you are, for example, watching a video and using, let's say, 3G or 4G, the video resolution kind of downgrades to match your bandwidth. But at no point is your viewing interrupted, right? There's no buffering. First it's HD, but then it goes to a low resolution. But then once you gain, you have higher bandwidth, the video goes up again. Same thing with pictures. You may notice when you're Twitter, when you're browsing through your tweets or your Instagram, for example, initially the pictures are low resolution. But if you click on it, you will get the high resolution picture. So hosting pictures, creating this experience for your customers for pictures and videos is not straightforward. There's a lot of work that goes into playing a simple video on the internet. And so there are services for that There are services specialized for storing videos, pictures, relational databases, non-relational databases. There are storages for operating systems. If you're a software developer, you would understand the necessity of having kernels of the operating system on the internet. File conversion, right? Let's say you have a dashboard for accounting, for banking, for let's take accounting, for example, right? And your clients will send you different types of files, PDFs, XML, CSVs, TSVs, JSON files, but you want to convert them into one file type. So in your backend, you have uniform data types. There's an API, you can do that with an API. Upload the file to that host and get back the converted version in a split second. Forex, foreign exchange. Let's say on your website, you're selling a product and you want to give your customers the ability to convert currency, to pay in their currency, but obviously the currency has to be in real time, right? Because currency obviously fluctuates. You can do that with an API. They will enter their amount. You will send that currency to a third party. They will convert it to you, give it back to you, and the customer can pay in the currency that they choose, the currency of their choosing. So you don't need to compute this. You don't need to build the algorithm that in real time somehow connects with other banking institutions to come up with the currency or with the latest currency. You can do that with a simple request. Traffic data. When I say traffic, I mean traffic in the physical world, like how much congestion there's in a highway. You remember that situation with the ship that blockaded everybody? What was that show? Evergreen? Evergreen, right? You can collect traffic data from airplanes, for the airspace, for shipping companies, for cars, for trucks, for people even. If you want to measure foot traffic, all of these types of data are available with APIs. If anyone has heard of geographic information systems or a platform called ArcGIS, okay? There's an API for that. These are very complicated things to compute, but if you pay a subscription fee and you know how to make a simple API request, something we'll look at today, by the way, you'll be able to have access to this service as well. Search. What's that? Illegal? When we
It's not illegal, or is it legal for the item?
no, of course it's legal. Of course it's legal. I mean, we talk about all kinds, everything.
You're trafficking the data, right? Okay, the person who has it is legal. He has the right to have it. However, to give it to me, is that legal?
That's a good question. Now, the question is, if we want to have access to traffic data, is that illegal? The answer is yes, or I should say, it depends. When we are sending to you traffic data, in most cases, it is anonymized. We do not know who the ship belongs to. We just know that it is a ship. But it depends. Depends on.
You're not interested in knowing who.
Exactly. So let's say you want to, you're a big enterprise company and you want to launch new stores, or you want to run a new ad campaign, and your ad campaigns need to be plastered on the highway. But you want to know if this highway even has that kind of movement. You can use traffic data. We don't care who's in the car. We just want to know how much car traffic we have on these roads. Also, in cases where there is scarcity of water is not available to distribute. You can use geographic information systems to find different sources of water, and in real time figure out how we can distribute these different sources of water. Search. Everybody knows the power of the Google search engine. YouTube itself is a powerful search engine, but there are other types of search engines. Let's say you want to give your customers the ability to search in another language, like Russian. Did you know that when it comes to the Russian language, the best search engine is not Google, it's from Yandex. You see, Russian that is written is very different than the Russian that's spoken, or the one that people use text. So you want to create that experience. You want to enter the Eastern market in Eastern Europe, or you want to go to East Asia, and you want to combine the search engines of Google, Yandex, and Baidu. Again, you can do that. If you can take search terms from your customer, they will type it in your search bar. You will take that search query. What do? Make an API request or make an HTTP request to the Google service, the Baidu service, Yandex service, any kind of search service, and you can get back the search results. Do you have to figure out how search algorithms work? No. Powerful service, accessible to you if you write a few lines of code. Web services, of course. Now this is a big one. In fact, in a subsequent slide, I'm going to show you an example of how modern applications are built, how cloud computing works. If you want to build a website, websites are no longer like only HTML and CSS. We have applications on web applications on which you can watch videos. You can play games. You can do AutoCAD. AutoCAD is a platform where engineers use to, for example, create the mechanical parts on the internet, in the web browser. You don't even have to download the software. So very powerful applications can be hosted on the web. There's a company who Angami. It's like Spotify for Arabic music. Small team of developers, but they have a huge base of customers. They were able to create or facilitate the computer requirements just by being in the cloud. How does that work? We'll see that in a subsequent diagram. Machine learning. Okay, again, this is relevant to you if you're a data scientist. You have data, all kinds of data, and you want to gather insight, and there are certain machine learning algorithms that you want to apply to this data. These machine learning models are built in the cloud. How does it work? Once again, you would make HTTP request, send your data, your CSV, your XML, whatever. And in your HTTP request, you can say, this is the machine learning model that I want to use. And what do you get back? The insight, the result of that computation. Computer vision is another one, right? You've seen how on Google, you can upload a picture and Google will find the contents of that picture and the sources the source of that picture. You can do that for your own application if you want. Here's an idea. I wish e-commerce companies would do this. Let's say you find a nice pair of shoes or a pair of bag or a laptop, but you don't know what brand this is or who sells it. Upload a picture of this product. You can snap a picture of this, upload it to the website, send that picture to computer vision service from Google, get back the information, what this is, where it can be found, what are the contents of this, and so on. Language translation. Again, this is similar to foreign exchange. Let's say you have customers from all over the world, and translation fees are expensive and time-consuming, but you want to be able to facilitate this in real time. Someone's on your website in English, but they're visiting you from Japan or Saudi Arabia, and you want to translate the UI, the text on the website, to Arabic or Japanese. Can you guess how we will go about doing this? Well, no, I mean, without Google Translate, yes, but with the Google Translate API. So you take the text of the website, send it, make an HTTP request to the Google API service, and you get back the translated version. Accounting, right? Think about the accounting, the different types of accounting you need to do. You have, you want to give your customers the ability, or let's say you want to directly charge them. If you're a B2B company, every month on a fixed day, you want to be able to charge them, withdraw money from their account. And you can do this with an API. And data streaming. Now, data streaming and web services, let me show you two diagrams to get this idea across. So far, what did we learn about? We learned what it means, what the word cloud means, what cloud computing means. We'll see that. We'll look at that in more depth in a second. We now know the definition of API. And we know that there are things we can do with an API. And of course, we'll look at an example very quickly. Does anyone know what this picture is? Has anyone seen something like this before? Does anyone recognize this? Simple yes or no? This is an architecture on AWS. Yeah, you'll find similar things on Google Cloud and Microsoft Azure. So remember those API services we talked about? Or not API services, or those cloud computing talked about? Well, we said there are different things you can compute on the cloud. There are different things you can compute on the internet. Now, if you want to build a modern web application, Okay, I'm talking about modern web application, not HTML, CSS that your, I don't know, 14-year-old cousin can put together. I mean a serious product. Okay, like you want to build something like Angami or Sarwa. Anyone know what Sarwa? The portfolio management application, right? Maybe Netflix. Netflix, by the way, they were able to scale because of cloud computing, because of these components that I'm about to explain. I'll tell you what these do in a second. But if you're a single person, I don't mean your relationship status, I mean you're an individual, right? You have a business idea, it needs a lot of computation power, and you know one programming language. If you attended our previous episode, remember that circle of, I talked about the top programming language. If you haven't, you can go back to the first episode and watch it. Let's say you know a programming language, you spent 2 months, 3 months learning a programming language. And now you want to turn your business idea into an application, a full-blown application, like a serious one, where people see it on the App Store or they see it on a website and go, this is legit, and they will be paying customers. But if you want to build something like that, you need all kinds of what's the word I'm looking for? Components. Let me show you let me take you through some of these components, and I'll explain the rules of these components, and you will start to see the complexities of modern applications. It begins here with the Amazon ECS service. You know, when you have an application, whether it's a mobile application, it's a web application, that application needs to run on an operating system. Okay? Remember the different types of programming language we talked about, C++, C#, PHP, Ruby, right? In order for the application to run, it needs to live in an operating system. So what you can do is, through AWS, you can choose the appropriate operating system for your application. Furthermore, you can choose how much computer specification or how much computation power you want to give this application. How much RAM, how much CPU, how much storage. If you have an application with lots of customers and they want to upload videos and pictures, you need plenty of storage, right? The kind of storage, the kind of speed they would find in a converged infrastructure. Remember that server stack? So your application is going to live in here. Do you remember how I said that pictures and videos are not simple to host? I give you the example of the YouTube video player or the user experience on Instagram, on Twitter. You see how when you are scrolling through the feed, it seems to be infinite. It just keeps on going. You can keep on scrolling forever. That is not simple to do. You're asking for a lot of data every time you swipe. So how do they make it instantaneous? Using something we call cloud delivery networks. That is what Amazon CloudFront is for. You know how CDNs work? Let's say you upload a video, 4K, 1-hour video to YouTube. But our friend here is watching it from, let's say China. He's watching it from Brazil. You're watching it from Kuwait. I'm watching it from Dubai. You're watching it from Germany. None of us experience any lag. Now, when he uploaded the video to the YouTube server is where? Where is the data center? Let's say it's somewhere in the United States. But are any of us in the United States? No. We're all in different geographical locations. Do you know how CDNs work? Have you heard that AWS is going to open 4 data centers in the UAE? Anyone heard of that news? Do you know what that means? Here's how it works. Companies like Google, AWS, Azure, they don't have one data center. They have many data centers in different parts of the world. Why in different parts of the world? Because if you're in Kuwait and you want to watch that video, you're not going to be making HTTP requests to the United States. No. You're going to be making an HTTP request to the Kuwait data center. You see, every single data center is going to have a copy of that same video. If he wants to watch the video, he's not going to be talking to the data center in the United States. He's going to be talking to the data center in China. He'll be talking to the data center in Japan. He'll be talking to the data center in Germany.
Efficiency, like just because he's going to use a different server that's closer.
Right. You eliminate latency. You eliminate delay. Everyone experiences everything quickly. Right? Every one of us know that we want everything. If there's a 2-second delay, we get frustrated, right? We put our phone down, we slam our fist, we yell at our spouse. You have high expectations. Are you going to be able to replicate this with your HTML and CSS skills? Oh, wait. Are you going to be able to build a data center? Oh, wait. Well, what you can do is have Amazon do it for you. So definitely your website is going to need the CDN. We talked about the necessity of ECS. You may also have customers who upload information. Their profile picture, maybe if you're an accounting service, they have, I don't know. They need to host stuff on your application as well. There's a service for that called S3. ALB, this is an important one. Let's say you have an e-commerce store, right? And you have customers from all over the world. Now it's New Year. And there's going to be especially more traffic to your application. ALB is a load balancer. The process of load balancing is to distribute the traffic across these data centers. For example, let's say it's let's think about a national holiday or a national celebration, like the Chinese New Year, right? Chinese New Year, people want to celebrate, they want to buy gifts for their family members. So on that particular day, you have a lot of traffic from China, not so much from other parts of the world, okay? What the load balancer will do is it will take some space or some computation power from the unused parts of the world and assign them to, let's say, the data center in China. You, as a customer of AWS, do not pay extra because of this holiday. Because with AWS, you can smartly reallocate services. And of course, when it comes to storage, we have all kinds of storage. We have storage for relational databases. If anyone know what these are, you have non-relational databases like the ones you see on Excel worksheet. But you have non-relational databases. This is something you want to look into. Graph database. Just make a note of that. If you ever wonder how social media applications are able to send and receive data so quickly, it is because of some sort of graph database implementation. And of course, your application may need access to files that are big and need to be accessed quickly. This is not data that is going to be used by a customer, but it's going to be used in your own system. There is a service for that. Now, this is a very simple architecture. Okay, all of these components that I talked about, this is relatively speaking a simple architecture. But you would need something like this if you want to live up to, if you want to, meet those expectations. Okay. Now for data scientists, and even if you're not a data scientist, this will give you some nice insight. If you're a data scientist, you want to have access to real-time data, so you can gather intelligence, like shipping company. There's a company called Kepler. So there's a small company, but they're very well known, and they have a highly valued service. What they do is they give intelligence about shipping companies. In fact, when that big ship caused traffic, they were the first company they reached out to, because these people they've built a system like this, and they're able to monitor ship activity all across the world and produce a nice, simple dashboard where you can visualize this activity. If you want to put together something of that sort, here's a sample architecture that can make it happen. So let's say you have these vehicles. You have passenger cars, buses, trucks. And these cars can send data to the internet, right? IoT devices. It doesn't have to be vehicles, it can be smartwatches. Let's say you want to gather analytics for your smartwatch customers. You want to see how much they use it or how much they struggle with those devices. There's a service from a suite called Apache Spark. There's a service called Kafka, which it's an event service, but basically what it does is these two together will collect information from all of these vehicles all over the world, and then you can put them into a database. This is a Cassandra. It's just the name of a database vendor. Okay, so with this system, you're able to collect data from all kinds of sources. It can be cars, but it can be your Instagram account, your LinkedIn account, your Facebook account, your website, your competitor's website. Let's say you're making API requests, you're making 10 API requests, you're gathering data, you're doing web scraping, you're gathering data. So you have all kinds of data and you want to bring them into one place. You can do that with Kafka and Apache Spark. Put them into a database, and then you know what these are? Chart.js, jQuery.js. These are small files with which you can visualize. You can create nice graphs, nice plots. So if you know some HTML, CSS, JavaScript, you can pull this data in and very simply create nice graphs for your customers. This will be valuable to your end user. They can have access to all of this valuable insight without even knowing without even knowing what's going on behind the scenes. Learn a programming language. Have clarity about the definition of API. Look at the example that I'm about to show you. This is within your reach. Okay. Now let's do a simple API example. Let me show you how easy it is. Okay. You know what these are? If you're a laptop user, if you're a Mac user, this is called a terminal. If you're a Windows user, it's called command prompt. If you don't have a laptop with you, I'll show you how easy it is. Okay. So what I'm going to do is I'm going to copy this code. You don't need to download anything at all. No application. Don't pay for subscription fee. But here's how it works. There is an application on your computer. It's pre-built. Now, let me point this out. There are two kinds of applications on your computer. There are applications that have interfaces, like Firefox here. When I say interface, I mean it has buttons. You can maximize, you can close, you can minimize, back button and forward button. And there are applications that have no UI interface. And the only way you can use that application is through the shell. If you have a shell on the Mac, we call it a terminal. If you have a shell on the Windows, we call it command prompt. Okay? You actually have a lot of background applications that you don't see them. But you'll know if you... Sure. Python, for example. If you want to run a Python script, what you can do is you can fire up the terminal and Python, you can run a Python script. Or for example, I want to know how many files I have on my computer. I can type in ls and I can get a list of the folders I have. Right now, I'm directly interacting with my computer. I'm not clicking on anything. I'm writing something called shell script. Now, this application, CURL. Can anyone guess what C stands for? It's kind of related to what we talked about. I talked about two terms. The one, a little bit after that. No. Who's the client? Client URL. A client making a URL request. And this is the website. This is a website, this typicode.com, where you can, it's just a dummy website where you can pull in data. So they say, if you make an HTTP request to this URL, we'll give you some sample data. This is their API. This is the rules. You don't need to pay for anything. You don't need any token. Just make this HTTP request. That's all they want from you. And just like that, I'm able to make an API request. So I'll copy this, and all I have to do is what? Paste. When I hit the internet, my computer is going to start to make an HTTP request, and then I will get this dummy data. So user ID is 1, ID is this, title is that. It's just lorem ipsum, dummy information. You can use the same, and this other mumbo jumbo you see here is just information about your HTTP request. You see this HTTP 200? 200, it just means it was a successful request. Whereas if you had received something like 500, that meant that the host is not responding. Something's wrong. And here it's telling you, for example, what type of file format has been exchanged. You know what file formats are. We have XML, we have CSV, we have MPEG-4, JPG. This particular file format is JSON. And here it is. You can, in fact, if I take you to the Google website, if I type in Google API, CURL, they'll show you how you can do this. Here, they have a website explaining how you can use CRL to interact with Google services. See that? Use this curl application, send your request this URL, and just enter your email and your, let's say, your password, and tell us what you want. For example, you have a name of a building, and you want to know its coordinates, longitude, latitude. You can use this to find out the longitude, latitude. In fact, all of these services can be accessed using the curl application. How long did it take for me to show you an example of an API request? A couple of seconds. Learn. If you learn it, you just need to learn 1 or 2 programming languages, ideally JavaScript. And you can start making API requests to any of these. Take the data and somehow visualize it on your dashboard, website, what have you. Okay. Like I promised, I wanted to leave a 10-minute window to answer any questions you have. Anything you want to know. So I'm open for questions. Yes.
So I don't know if it's relevant to what you thought, but I've had this question for a while. There are a lot of these websites that give you this free, like what you saw there.
Right. Yes.
Thing. Now, on a lot of these websites, there's no ads or anything like that. Why would you do this for free?
Can you give me an example? So again, for those in the
like,
Zoom.
Let's say like a paste bin.
Paste it?
Like a paste bin.
Paste bin.
I don't know that the website still exists.
Okay.
But you could just paste some text over there. It would create a link, and you can share the link with your friend or something, and
right.
They'd be able to access the text.
So the question is, there are some websites out there that give you free service, right? For example, you can convert files, or there's Pastebin like you mentioned. Even Google, you can spend up to $300 of their service for free. Well, why do they do that? Well, let's think about it. It's kind of like when you go to a supermarket and you always have this tiny booth in the middle of the supermarket and they give you samples of the food.
I understand for you Google, because they're trying to convert you into a page.
Well, it's the same thing for them. You may have noticed, you didn't mention they don't have advertisements.
Yeah, no advertisements, nothing. There's a guy paying.
And there's no way to upgrade to their service?
No, your Pastebin was just this.
It could.
Maybe just for portfolio.
It could be just.
Maybe
That's a good one. That's a good one. They could be collecting data. They want to know what kind of how Pastebin is being used. And once they have data, you go, we know what to build for our customers. It's a very good idea. Any other questions? Everyone wants something. Okay.
Exactly.
If they don't take it from you, they probably take it from someone else. Yes. Any other questions about what we talked about? Maybe related to this, or not necessarily. So, anyone have a question?
In the internet nowadays, there's a shortcut for everything.
Right.
So is there a shortcut for this without learning a language?
So the question is there a shortcut for learning, right?
Yeah.
Is there a shortcut for learning these? What's your definition of shortcut, first of all?
Like without learning a language, for example. So
Without learning, yes and no. You can get away without. We can put together an application. You can make money without learning how to code. There are platforms through which you can build applications through drag and drop. Okay.
You mean the APIs, right?
No, I'm not talking about. I'm talking about. Let's say you want to build an application. You have a business idea. You want people to pay with their credit card.
No, I'm asking about the APIs. Is it possible to build an API without learning?
So again, remember the definition of the word API: rules for two computers talk to each other. So how can you write the rules if you do not know how computers talk to each other? You see where I'm going? How can you make rules if you do not know how the rules work? So you do have to learn how computers work in order to put together an API. Of course, you can always pay someone to do it. But this is not difficult to learn. If you focus on something specific, If you've watched the previous video, I told you there's a lot of programming languages. They all have a specific purpose. Choose one, stay focused on that, and it shouldn't take you forever to do. Any other questions? How about those in the chat? No?
I have one question.
Yes.
So you mentioned about the CDN.
Right.
They make copies in almost all data centers.
Correct.
So then how these outrages happen sometimes? So, why?
That's a good question. Now, if you go to a company like AWS, the question was, by the way, if we have, we have these CDN services and they replicate, let's say, your file all over the world, but sometimes they have outages. Why do outages happen? It depends on who the vendor is, but a company like AWS guarantees, it's on the website, they guarantee 99.99% uptime. That's a very in-depth, like I'm really going deep just to convince you why it would not happen. But let's say in one particular data center, they don't have just one computer that holds onto your files. They have redundant computers. Just in case, actually, in some cases, they have 5 computers. If the first one, I don't know, fails for some reason, there's a short circuit. There's no second one to back it up. If something happens to the second one, immediately there's a third one to take it over. If something happens to the third one, by some unusual circumstance, there's a fourth one. In the event all 5 are destroyed, AWS has this, let's say, provision where they will move all of your data into a close-by data center. Actually, I've done a workshop that's an hour long just on security, because people are one of the questions that comes up is, okay, cloud computing, beautiful, love it, I love it how it sounds. I don't trust it. How can I be sure that if I give them my data, they won't pry into my data? They won't take, they won't take my baby away from me. They won't take my intelligence. Lengthy topic. I cannot address this in a few minutes, but let me put it to you this way. Companies or institutions with the most sensitive type of data leave the data with cloud computing. I'm talking about the what do you call the Department of Defense in the United States, intelligence agencies, banks, Goldman Sachs, JP Morgan, Philips Healthcare. Philips has a lot of information about patients. They leave their data with AWS. Is it because they trust AWS? Is it because they like how Jeff Bezos looks? No. AWS is subject to all kinds of auditing. Third-party companies that audit every single aspect of this web service must certify them. It's a lengthy process, but if these companies can trust them, they not trust, but they verify that the data is safe, your company or even if you're a startup, you can do it too. I would suggest you go to AWS, look at the certifications they have, and understand what it means to be certified by those organizations, and you will hopefully be convinced. But again, the security measures are so extensive, I can't cover them in a couple of minutes. All right, so if you have no questions, let me give you some suggestions. If you want to get into data science or application development. If you want to get into data science, if you want to know, gather data and gain insights, the suggested programming language for you is Python. Okay, Python is the king in the world of data science and machine learning. If you want to get started with building applications, desktop applications, mobile applications, web applications, small applications, big applications, the programming language right now that is dominant is JavaScript. Both of these 2 languages have something in common. They're very simple to learn. They are very simple to learn. In our bootcamp, we have a data science bootcamp, data science and machine learning bootcamp, we have a coding bootcamp. In both of these bootcamps, we teach them the building blocks in a week. Meaning by the second week, they are building small programs. And every subsequent week, if they're in the data science bootcamp, they're able to do statistical analysis. If they're the coding bootcamp, they're building projects. They're building an application, and this application gets progressively more and more sophisticated with every single week. My point here is that these two programming languages are easy to learn. You can learn it very easily. So do not be intimidated. If you've never written a line of code, do not be intimidated. But if you want to choose a language, choose either JavaScript or Python. And if you choose to learn one or the other, and you choose to change at one point, it will be very easy to switch because they're very similar. You have the question?
Yeah.
Yes.
What's the best ETL tool you suggest to go with the Python?
Say again?
ETL.
Best ETL for Python. ETL is like a collection of tools, right?
Yeah, like I've been using Azure.
Extract, transform.
Azure Data Factory, that's what I'm using right now. But I think that it is not really.
Right now, so if you want to do data science, right now, there is no technology that touches, not even comes close to Apache Spark. The whole ETL process.
That's all big data.
Yeah, but if you want to be a data scientist, you want big data.
Talking about more of the statistics data.
Statistics data, you can use pandas. Pandas and NumPy. Pandas.
But for ETL, like, how will I fetch the data directly from the server?
If you, okay, so like I said, so Apache Spark is comprehensive. It's like everything is built in. If you're not that, then you have to kind of install those libraries independently in Python. Here's my suggestion for you. You can get started with Apache Spark without configuring or installing anything. There's a website called Databricks. Have you heard of it?
No.
You know how to program with notebooks, right? You know what a notebook is. You know what a notebook is, right? Jupyter Notebook. Jupyter Notebook.
Yes, I'm working on it.
Databricks is Jupyter Notebook on the cloud with Apache Spark built in. Now, we've reached the end, but start with that. Create an account. Since you know what a notebook is, you can get started. They will give you some sample code as well. So that's what I would point you to. But therefore, the answer is Apache Spark. At any rate, we've reached the end of episode 2, everybody. I hope you found this useful. Our next session, our third episode is next Monday. So I hope to see you there. But in the meantime, enjoy your evening, and I'll see you soon. Bye, everybody.
Thank you.
Thank you.
Thank you.